we're going to go down the line. I'm going to give you binary numbers, and you guys convert them for me, okay?
So the base 10, I'm guessing?
Yeah.
Is it a race?
Go.
I want you to convert it to decimals. Yeah.
Okay.
Go ahead and go. How your finger thing?
What? Oh, I'm like, it's not even fair. You can keep going. No, I don't.
Go ahead. It's not a race. It's not a race. It's not a race. I'm just trying to get numbers to you.
Well, I've really kind of forgotten this. Yeah, just oh. Well, A. What? Oh. How much?
Can I get the race? Can I get the?
Yeah.
Yeah. That's it. Oh, we're just waiting for you to say go. Oh, that's all right.
Okay.
Oh.
Now write your number down on a Post-it note for me.
You put me on the spot.
Which one?
What?
Put your decimal number on a Post-it note.
Okay.
Just write it really big. Just write your number real big and
This?
pass it down. Now you can keep the.
Can we keep it?
Keep your Post-it.
Okay.
Everybody hold your numbers up. Okay? Now what I want you to do is sort yourselves from smallest number near me to largest number down by Wade. They did it. Okay, and now I want you to tell me, what did you do as a human to sort yourselves? How did you know where to go? What did you do? How
I
to
only
describe
looked at
that?
the person next to me.
Compared them 2 by 2.
You compared 2 by 2, right? And then you looked at someone else's, and then you kind of put yourself in the right place and moved on down, right?
Mm-hmm.
Okay, so what we want to do now is capture that idea in a machine. So let's give them all one card. You're all good back now. So we do this with our students. It helps reinforce binary numbers, and then it leads us into the idea of sorting. So what I'd like to talk about now, what if I had to create a little machine that would sort 4 numbers? So the idea in this case, I would have 4 numbers here. I have some kind of box representing the machine. And coming outside of the box would be another 4 numbers. And it would be such that the smallest would be on top and the largest would be on bottom. They'd be sorted from top to bottom. So how would you create a machine to do this? So I have 4 inputs, and I feed them into this box, this machine, and out comes the real answer. So what were the numbers again that we had? I had 13, 15, 9, and 12, right? And so when I put these into this machine, I want the answer to come out as 9, 12, 13, and 15. So how do we do this? Any thoughts? So what did they say that they did as humans?
Give the machine
Compare.
2 hands to pick up 2 things.
Okay, they compared 2 things. So why don't we compare these 2 things? Let's bring this thing in and compare it. Let's bring these 2 things in and compare them. Okay? So now that I know I can compare these, if I want the smallest one to go this way, I want the largest one to go this way. In this case, I want the smallest one to go this way. I messed it up, didn't I? I want the smallest one here to go up here, the largest one to go here, and the largest one to go here. See that? I'm doing a pairwise thing here with the 4 values. So the smallest one from this goes up here, and the smallest one from here goes up here. Logically, what do we know about this? If I do this other comparison here, what do I know about the smallest one? It has to be the smallest of all. Because if you're the smallest of this one and you go up there, and you're competing against the smallest one down here, you know that if you're the smallest one there, you must be the smallest overall. And what about the largest at the bottom? If you're the largest, if you made it to this round and you're the largest, you must be the largest overall. But we really can't say anything yet about these two. So we have to do one more round of comparison. So the largest one here is being teamed up with the smallest one here. And where do you think the smallest one will go? Which slot? The second one. And then the large one goes here. So let's see if this works. Let's play it with these numbers over here that they did. So 15 and 9, they come in here and compare. Which goes to the top? 9. 15 down here. Now I compare 13 and 12. Which one goes to the top? 12. And 13 down here. Now I compare 9 and 12. Which one is smallest? 9. I compare 15 and 13. Which one's largest? 15. So I have the 12 going here and the 13 here. So now, out of this, which one goes to the top? 12. And I have 13. So those are sorted now. I just built a machine that will sort 4 numbers. Now, we teach this to 5th graders. I'm not kidding you. What we do with the 5th graders, this won't work well for your high school class. We go out on the playground and we draw this machine with chalk. We have to draw it pretty big. And then we have the kids, 5th graders learn binary numbers. You can teach that to 5th graders. In fact, the record, I didn't do it with you all, but what I do this other skit where I have a bunch of binary numbers, and you have to play this thing we did with our fingers, but you do it with cards. And the record is by 5th graders. So 5th graders actually have the world record, or the record, they beat most of the adult records. They did it in like 45 seconds. I asked them to count from 1 to 15. So, and the adults are kind of fumbling around, and for that one show, Are You Smarter Than a 5th Grader? So sometimes 5th graders can count in binary faster. But the neat thing is that will sort, the kids can go out on the playground, they all want to try this, because they're like comparing themselves, and it's a kinesthetic kind of movement, they're having fun with it, and they learn a little bit about sorting. And so the next question we ask, which we won't get into here, we'll do on the MOOC, that works well for a machine that takes in 4 inputs. What if I wanted to build a machine that took 1,000,000 inputs? Good luck drawing that one, okay? I'll go off and eat lunch for the next 80 years, and you'll still be drawing that machine. That's going to take you a while. So we talk about not so much building physical hardwired machines to do this, which may have been what we did 100 years ago when we had to do something mechanical. We now talk about an algorithm, which is an abstract kind of expression for solving a problem. And we lead into a discussion of sorting algorithms.